Go. Hot water system design. Yung figure na yun is a hot water system, yung mga water heater, plus yung mga gauges, temperature gauges, pressure gauges, kailangan mo yan para ma-monitor yung temperatures. Hot water system design, careful planning required. So proper design of the domestic hot water supply for any building is extremely important. Careful planning on the basis of all available data will ensure an adequate supply of water at desired temperature to its fixtures at all times. A properly designed system must of course conform with all regulations of authorities having jurisdiction. The objectives to achieve in the design of an efficient hot water distribution system include A. Providing adequate amount of water at the prescribed temperature to all fixtures and equipment at all times. B. A system which will perform its function safely. C. The utilization of an economical heat source. D. A cost-effective and durable installation. E. An economical operating system with reasonable maintenance costs. Safety devices. Many cases have been reported where the explosion or bursting of tank, damage to property, and scalding and injury of person have occurred due to hazardous pressures and temperature. Standard plumbing equipment, including hot water heaters and storage tank, is designed for a working pressure of 125 psi. Any pressure in excess of this 125 psi limit can therefore be considered hazardous. Water expands as it is heated. The increase in its volume for 100 Fahrenheit temperature rise can be calculated to be 1.68% of its original volume. Since water is considered to be incompressible, the increased volume results in a build-up pressure. It is absolutely necessary to provide a positive means of relieving this excess pressure. A pressure relief valve or combined pressure temperature relief valve satisfactorily meets these requirements. Yan ang safety device niya. Every hot water, meron niya. A brief outline of some common sources of hot water supply will set forth their main characteristic and limitation. So ito yung mga sources. Directly heated automatic storage heater. In this category are placed the simple gas, propane-fired, or electrically heated storage tank heaters used so universally in homes, apartments, smaller institution or establishment. Size ranges from 15 to 100 gallons storage capacity, 25 to 98 gallons per hour recovery rate with 60 degrees temperature rise is generally found. Heat input normally ranges from 10,000 to 70,000 BTUs per hour. Okay. Instantaneous heater. Instantaneous type of water heater must have sufficient input capacity to meet all demands simultaneously. These heaters have no built-in storage volume because they are designed to supply the full load instantly and continuously. The flow of fuel, gas, or liquid is automatically controlled by the flow of water in an on-off or modulated flow system. The water flow rate, temperature, and heat input are fixed at the factory. Heat input must be high in order to ensure the required flow of hot water. Efficiencies because of these high flow rates and typical on-off operation are lower than the storage type. Capacities run roughly from 1.5 to 10 gallons per minute. Heat input rates run approximately from 150,000 to 200,000 BTUs per hour. So, malaki yung konsumo. So ito yung figure 1 is the conventional YouTube instantaneous water heater. Direct siya. Steam inlet, condensate, tapos yung water mo taas. Hot water out. Ito naman yung straight tube. Hindi siya nakayo. Floating head. Yung head niyan, ka-float. Pasok dito, labas to. Yan. Steam inlet. So, booster heaters. The term booster is applied to describe the function or purpose of the water heater. Heaters may be the ordinary standard instantaneous type, but they serve to raise the temperature of regular hot water supply to some higher temperature needed to perform special function. So normal temperature mo, halimbawa, nakaset lang doon. Meron kang isang unit na kailangan mas mataas temperature, so kailangan mo ng booster. The advantages in the use of booster heater are A. Only as much water need be heated to above normal system temperature is required for the specific job. The larger normal use throughout the building can be averaged or average hot water at lower temperature. Sa iba ayaw nitong magdagdagan ng unit. Kasi isa lang. Mas malaki yung unit mo kasi pinag-isa mo sa temperature na highest. Pero isa lang pagagamitan mo. Iba kasi kliyente, ba't may isa pa? B. Savings and investment. Maintenance and operating costs are derived from the limited use of very hot water. Letter C. Small boosters can be located near their job with simple control, minimum waste, and smooth operation. Next is the semi-instantaneous heaters. To overcome the shortcoming of instantaneous heater, manufacturers have developed a limited storage type heater, which is known as semi-instantaneous. This type of heater contains between 2 to 20 seconds of domestic water storage, according to its rated heating capacity. A 60 GPM rated heater will have approximately 20 gallons of water in its shell. This small quantity of water is adequate to allow the temperature control system to react to sudden fluctuation in water flow and to maintain the outlet water temperature within plus or minus 5 degrees Fahrenheit. The temperature control system is almost always included with the heater as a package. So ito naman yung conventional storage water heater. Yan, dito yung storage tank. Okay? Relief valve, water outlet, ayan mga fittings. Ito, lifting lang yan. Ito yung saddle. Sizing instantaneous type water heater. The selection of the instantaneous heater is a relatively simple and straightforward procedure. The most acceptable method is probably the one based upon the fixture unit method. This has already been covered in the design procedure for sizing domestic water system. It has been found, however, by more than 15 years of field tests that peak demand for hot water determined by this method is 2 to 3 times the actual demand. It is therefore recommended that the following usage factor be applied to select the most economically sized instantaneous water heater. Use 0.5 for hospital and hotel, 0.33 for residential, and 0.25 for office building. When the peak demand has been determined, a heater is selected which will deliver the demand. Sample 1. The fixture unit method indicates a peak demand for a hotel of 125 GPM. Assume the water is to be distributed at 120 Fahrenheit. May kayo ng temperature ng water. 120 Fahrenheit with inlet water at 40 Fahrenheit. Then, the heater must deliver 125 times 0.5 or 62.5 gallons. Kasi yung, 0.5 is hospital or hotel. Hotel, 0.5. Yung factor. Of 120 Fahrenheit water per minute. The BTUs per hour required are calculated by multiplying GPM by 500 by 120 minus 40 times the usage factor. So thus, BTU per hour is 125 times 500 times 80 times 0.5 is equal to 2,500,000 BTU per hour, where 500 is 60 times 8.3 or 8.333. Yeah. So ito yung capacity mo ng water heater mo instantaneous time. The selection of sizing of the storage type heater naman. The selection of the storage type heaters is far more complex and due to the many proposed method can be extremely confusing. It would be an exercise in futility to analyze all proposed methods. The plumbing designer is fortunate that the results of many years of research have been made available during the past few years. The reports have been very well received by the engineering community, and the older empirical procedures are rapidly being discarded. There are two basic determinations that must be made in order to design a water storage tank heater. One, the hourly peak demand, and two, duration of that peak demand, ilang minutes. Table 1 gives the necessary data to determine the hourly peak demand for various types of building, as well as other pertinent information. The duration of peak demand is given in Table 2, as well as an alternate method of determining the hourly peak. So Table 1, hot water demands and use for various types of building sa ASHRAE Applications 2015. This is Table 6 doon. So ito yung mga type ng building. Maximum hourly, maximum daily, and average daily. Men's dormitories, andyan, 3.8 gallons per student. Maximum daily, daily to, 22 gallons per student. So average daily, 13.1 gallons per student. Okay? Pag kukuha ka ng monthly, ang gagamitin mo is average daily times 30 days, 22 days, 25 days na. Kasi yun mo yung average daily. Ito maximum daily is once lang to, once or twice lang na maximum. Ganyan ang paggamit niya. Huwag mong maximum tapos multiply mo 30. Alam ko eh, si average na kinuha, hindi naman lahat araw-araw. Average daily. Tingnan natin. So, ito yung table 2, estimated hot water demand characteristic for various types of building. So, the resident, by building naman to, office building, factory, yan, 22. 2 to 3 gallons. Hot water required per person. Maximum hourly demand in relation to days use, 1/5 of a day. Duration, duration of peak load hours, 4 hours to 1 hour. So, ito yung nakuha mo yung peak, average peak dito. May example naman yun, diba? Maximum, yan, hourly. So, multiply mo to, yun ang, ano mo, dito. Requirements. Storage capacity in relation to days use. Heating capacity in relation to days use. So, may example naman dito. The total capacity of a hot water storage tank is not usable capacity. As hot water is blown from the tank, cold water enters and due to unavailable mixtures with the hot water in the tank, temperature of the water limit is lowered. When 60 to 80% of the total tank capacity has been blown, the temperature of the water limit is at an unacceptable low level. It is recommended that 70% of the total tank capacity be considered usable. Okay, may example naman tayo dyan. Okay. So figures 4 through 11 shows the relationship between recovery and storage capacity for various types of building. The required recovery capacity is the difference between the peak hour demand and the gallons per hour available from the tank. As an illustration, if we have 1,000 gallon tank and a peak demand of 450 gallons per hour, which lasts for 2 hours, then yung gallons plus 1,000 times 0.7 is 700 gallons of usable hot water. 700 divided by 2 is this is 2 hours. 350 gallons per hour available. So 450 minus 350 is equal to 100 gallons per hour recovery capacity required. When peak demand and the duration of that demand is known, it is possible to select any number of combination of storage and recovery capacity to satisfy the requirement. Any combination of storage and recovery that falls on the curve of the particular type of building shown in figure 4 to 11 will satisfy the requirements of the building. Selection of the minimum recovery capacity and the maximum storage capacity on the curves will yield the smallest hot water capacity capable of satisfying the building demand. Minimizing the recovery capacities will place less of a demand on that heat source. So ito yung figure 4 to 11. Ayan. Ito yung sample. Usable storage capacity. Meron kang equivalent na recovery capacity. So the recovery capacities shown are for the actual hot water flow required and do not reflect the system heat loss. Heat losses from the storage tank and circulating hot water piping must be calculated and added to the recovery capacity shown. So ito yung mga heat losses normally sa steel, EI pipe. Yan, meron yan. Pero sa PPR, negligible yan. So hindi na naglalagay ng circulating pipe. So the following sample taken from ASTE Handbook and the American Society of Plumbing Engineers Data Book clearly illustrate the use of tables and curves for selecting storage and recovery capacities. Okay, may boot dito. Okay, so ito na yung figure 4 is for dormitories. Figure 16 ito sa ASREA 2015 edition. Women, men, so this is the recovery rate in gallons per hour per student. Ito naman, usable storage capacity, gallons per student. So storage type. Ito naman, figure 5 is a motel, 100 or more rooms, 60 rooms, 20 or fewer rooms. So in between, pwede kang mamili. Okay, andito naman yung gallons per hour. So ito naman, usable storage capacity, gallons per bed, and recovery capacity, gallons per hour per bed. Figure 6, nursing homes. Office building, yan. Then food service, type A, type B. Type A, full meal restaurant and cafeterias. Type B, drive-thru, sandwich, and snack shop. So mga type ng kainan. Yung mga snack lang to. Drive-thru. Apartments, yan. 20 or fewer apartments. 50 apartments, yan. So example 2, determine the required water heater size for a 300 student women's dormitory for the following criteria. A, storage system with minimum recovery rate. B, storage system with recovery rate of 2.5 gallons per hour per student. With the additional requirement for a cafeteria to serve a maximum of 300 meals per hour for minimum recovery rate, combined with item A, and for a recovery rate of 1.0 gallons per minute per maximum meal per hour combined with B. Yan. Dormitory and cafeteria yung isa. Ito C. So, solution. So, with the given required, so solution tayo. A. The minimum recovery rate from figure 4 for women's dormitory is 1.1 gallons per hour per student. Ito, hanapin mo yung moment, tapat mo dyan. So, ano yung value niyan? 1.1. Or a total of 330 gallons per hour recovery is required. Bakit 330? Times mo na 300 yung 1.1, that is 330. Total storage required is 12 gallons per student or 3,600 gallons storage. Sana magaling itong plan. Ito. Yan, dapat na dito is 12 gallons. On a 70% net usable basis, the necessary tank size is 1.43 times 3,600 or 15150 gallons. Ito yung tank na kailangan mo. 1.43 is the reciprocal of 1/0.7. Danyan yan 1.43 is the reciprocal of 0.7. So letter B, the same curve also shows that 5 gallons per student Ano? 2.5. At 2.5 gallons per hour recovery. Hanapin mo yung 2.5 ito. E, ganun mo siya. So, lalabas dito is 5. 4, 5, 6, 7, 8. Okay. So, 300 times 5 is 1,500 gallons storage with a recovery of 300 times 2.5 or 750 gallons per hour. So, the tank size will be 1.43 times 1.5 or 2,150 gallons per hour. Yan. So, maliit. Depende nga sa recovery mo. Itong recovery, ito yung tumatakbo. Yung storage, yung natin iwan dun sa tanke. Pag for emergency use yun. Okay? See, the additional requirement for a cafeteria can be determined from the recommendations for food service establishment with the storage and recovery capacity added to that for the dormitory. For the case of minimum recovery rate, the criteria required is 300 times 0.45 or 135 gallons per hour recovery rate. Ito yan. Per maximum gallons per hour per maximum meals per hour. So, as 300 students siya. So, yan. 300 times 445. Yun na rin yun. So, ang baba niya is 7. So, 300 times 7 times 1.43 still ang gallons of additional storage. So, the entire building then requires 330 plus 135 or 460 gallons per hour recovery and 5150 plus 3,850 gallons of storage. Diba? So, nakuha mo yung tangke niya. At water storage tank na. Okay, diretso. Now, with 1 gallon recovery per maximum meal per hour, the recovery required is 300. With 300 times 2 times 143 is 860 gallons of additional storage. Bakit 300 lang? Kasi 300 times 1. 1 lang, di ba? So, tapos dito 2. Yan, 2. Okay. Combining this with item B, the entire building requires 750 plus 300 or 1,050 gallons per hour recovery and 2,150 plus 860 or 3,10 gallons of storage. Note, recovery capacities shown are for heating water only. To this capacities, additional capacity must be added to offset the system heat losses. Okay. Later na yun. Wala namang heat loss o konti. O percentage na lang yan. Sample number 3. Determine the water heater size and monthly hot water consumption for an office building to be occupied by 300 people. A. Storage system with minimum recovery rate. Storage system with 1 gallon per person storage. C. Additional minimum recovery rate requirement for a luncheonette open 5 days a week, serving a maximum of 100 meals in 1 hour and an average of 200 meals per day. So, unahin natin yung office. A. With minimum recovery rate of 0.1 gallons per person from figure 7 or 19. Yan, 0.1 minimum. 30 gallons per hour required. 300 times 0.1. While the storage is 1.6 gallons per person or 300 times 1.6 is 480 gallons per gallon storage. The tank will be sized as 1.43 times 480 or 690 times or 690 gallons. Letter B, the curve also shows 1 gallon storage per person. Ito, at 0.175 gallons per hour per person recovery or 300 times 1 gallon storage with recovery of 300 times 1.175 552.5 gallons per hour. The tank will be size 1.43 and 300 or 430 gallons. Ito yung little B, 1 gallon per person storage. C. The hot water requirements for a luncheonette are contained in the recommendations for food service establishment. So, type B tayo. Luncheonette, hindi naman siya restaurant. So, the recovery versus storage curve shows the minimum with minimum recovery capacity of 0.25 gallons per hour per maximum meals per hour times 100 meals would require 25 gallons per hour recovery. This is 100 meals per hour, average 200 meals per day. So sa per hour mo, so you have 1 times 300. In 1 hour and an average of wait. So ito, yan, 25 gallons per recovery. While the storage would be, yan, 2 gallons per meal or 100 times 2 times 1.43. Ito yung per hour. Huwag din natin gamitin yung per day kasi per hour ang issue dito. So the combined requirement with item A would then be 55 gallons recovery. Add mo yun. 30 plus 25 is 55. So this is 976 gallons storage. So i-add mo doon sa A. So combined with item B, the requirement will be 77.5 gallons per hour recovery and 716 gallons storage. Okay. So now, from table 1, the office building, ano ba po? Tingnan natin na. Tama, office building to. So, hindi kasama to sa detail D, sa required. Inandag lang. So, per day, from table 1, the office building will consume an average of 1 gallon per person per day times 30 days times 300 people is 9,000 gallons per month. While the luncheonette will consume 0.7 gallons per meal by 200 meals per day. So dito naman gamitin yan. Times 22 days a month, assuming na 22 days. So 3,080 gallons per month for a total of 12,080 gallons per month. Ito na yung required mo ng per month. Hindi yung requirement ko, hindi ito size ng tangke. Ito yung makukonsume mo. Saan galing itong 0.7? So, yung sinabi kong 0.7 doon, ito yan. 0.7 gallons per average meals per day. Di ba? So, ito. Ito mo gagamitin. Pag kung nag-compute ka ng monthly sa consumption. So, punta tayo ng table 1. Ito nga pala yan. Ito. Yung average daily, 1 gallon per person, plus 0.7 naman sa meal. Yan. Okay? Yun ang gamit ng table na to. Yan. Example 4. Determine the water heater size for a 200 unit apartment house. A. Storage system with minimal recovery rate with a single tank. B. Storage system with 4 gallons per hour per apartment recovery rate with a single tank. C. Storage system for each of two 100 unit wings. 1. The minimum recovery rate. 2. The recovery rate of 4 gallons per hour per apartment. Kasi hatiin mo ng dalawa, di ba? Magiging tig 100. So, mayroon siyang dalawang tangke. Solution A. The minimum recovery rate of Figure 9 for apartment buildings with 200 apartment is 2.1 per apartment, or a total of 420 gallons per hour recovery is required. So ito, 130 or more apartments dito ka. So, meron kang 2.1. Tumaas siya. Hindi siya 2, 2.1. Ito. Tapos sa baba, the storage is required is 24 gallons per apartment, or 48 gallons. Based on 70% of this hot water being usable, the necessary tank size is 1.43 times 48 is 6,860 gallons. Now, the same curve also shows 5 gallons per hour. 5 gallons storage per apartment at 4 gallons per hour recovery. This is 6, 5 to. Magiging 4 gallons per hour. So 200 times 4 is 800 gallons per hour. The tank size will be 1.43 times 1,000, or 1,430 gallons. Ang galing to, 1,000 is 200. Ito, 5 times 200 to. Hindi na naisingit. 5 times 200 is 1,000. Okay. Alternate solution for 200 unit apartment house with 2 wings, each with its own hot water system. In this instance, the solution for each 100 unit wing would be with minimum recovery rate of 2.5 gallons per hour per apartment from the code. 2.5 gallons per hour recovery is required. Ito yung 100, di ba? Tapos, while the necessary storage is 28 gallons per apartment, or 128 or 28 gallons. So the required tank is 1.43 times 200 is equal to 4,000. 1.43 times 2,800 is equal to 4,000 gallons for each wing. Number 2, the curve also shows that for a recovery rate of 4 gallons per hour per apartment, this storage would be 14 gallons, or 100 times 14, or 1,4 gallons with a recovery of 100 times 4, or 400 gallons per hour. The necessary tank size is 1.43 times 114 is equal to 200,000 gallons in each swing. Okay? Again, yung note. Sample number 5. Determine the water heater size and monthly hot water consumption for a 200 student high school. So, school naman tayo. A. Storage system with minimum recovery rate. B. Storage system with 4,000 gallons maximum storage capacity. Solution A. With minimum recovery rate of 0.15 gallons per hour per student from figure 11 for high school. So yan, 0.15 minimum. 300 gallons per hour recovery is required. So 200 I think may mali. So this is 2,000 para magtali. Kasi nga yung ano? Okay. 2,000 students siya. So mali sa magkasulat sa reference kukopya. Okay. So yan nga. So this is 300 gallons per hour recovery is 2,000 times 0.15. Yan. So the storage required is 3 gallons per student, or 2,000 times 3, or 6,000 gallons per student. The tank size is 1.43 times 6,000, or 8,600 gallons. Okay? So sa inyo, pag solusyon nyo, ipakita nyo lahat yung operation. B, the net storage capacity will be 0.7 times 4,000 if the maximum storage capacity is 4,000. So or 1.4 gallons per student. So 2 divided by 2,000. From the curve na 1.4, natin mo dyan, makikita mo yung 0.37 gallons per hour per student recovery capacity. So 0.37 times 2,000 is 740 gallons per hour recovery rate. Yan. Ulit, itong gallons per hour, yung tumatakbo. Tapos yung meron siya nakakabit na storage tank, backup niya. See from table 1, the monthly hot water consumption will be 2,000 students times 1.8 gallons per student per day times 22 days is equal to 79,200 gallons. 22 days kasi work. Saturday, Sunday, wala naman. Okay. 1.8, ito. Junior and senior high school, 1.8 gallons per student. Sample number 6. Okay. Determine the required heater capacity for an apartment building housing 200 people. If the storage tank has a capacity of 1,000 gallons, what heater capacity will be required if the storage tank is changed to 2,500 gallons? Solution. Assume an apartment house housing 200 people. From the data in table 2, daily requirements is 200 times 40. Ito yung hot water required per person. Apartment is 8,000 gallons. So the maximum hours demand is 8,000 divided by 7 is 1140 gallons. Maximum hours. Duration of peak load is 4 hours. Water required for 4 hours is 4 times 1150 is equal to 4,560 gallons. Diba kasi gallons per hour yan eh. Diba? Maximum hourly demand. So if 1,000 gallons is used, hot water available from the tank is 1,010.7 or 700. Water to be heated in 4 hours is 4,560 minus 700 is equal to 3,860. So heating capacity per hour is 3,860 over 4. So ito yung heating capacity per hour. 360 over 4 is 965 gallons per hour. Yan. You divide sa ano siya, duration of peak load kasi itong given yung peak load. Pag daily ito. Yan. So if instead of 1,000 gallon tank, a 2,500 gallon tank has been installed. So the required heating capacity per hour would be 4,560 minus 25 times 0.7 divided by 4 is 702 gallons per hour. Okay. Table 3 may be used to determine the size of water heating equipment from the number of fixtures. Kung available yung mga tao, bilang ng tao. If may fixtures na, so ito na. At water demand per fixtures from table from various types of buildings. So ito, isang method to. To obtain the probable maximum demand, multiply the total quantity for the fixture by the demand factor in line 19. So ito. Ito yung mga basin, bathtub, dishwasher, kitchen sink. Ito yung sa apartment, sa club, gymnasium, hospital, industrial plant, at yung mga value. Tapos, alito naman yung factor niya. Pag tinotal mo lang, ito yung factor. Yan. Tapos, yung storage tank, ito naman capacity factor. The heater capacity, ito. The heater or coil should have a water heating capacity equal to this probable maximum demand. The storage tank should have a capacity equal to this probable maximum demand multiplied by storage factor, capacity factor, and line 20. Example 6 will illustrate the procedure. Yan. So ito, as at pwede itong gamitin to. Or gamitin yung una, ginawa natin. Palin yung mas malaki, yun na gamitin niya. Okay. Example 7. Determination of heater and storage tank size for apartment building from number of fixtures, 60 laboratories. Apartment, ito on apartment. So laboratories is, wala. Ito, 2. Sabihin natin private, 2. So 120 gallons per hour. 10 bathtubs times 20 is 600 gallons per hour. 30 showers times 30 is 900 gallons per hour. Ito siya. Di ba? 15 laundry tubs times 20 is 300 gallons per hour. Wait may nagugulgul dyan. Ayan. So the possible maximum demand is 2,500 gallons per hour. So the probable maximum demand is 2520 times 0.3 or 756 gallons per hour. 2522. So yan. Heater or coil capacity is 756 gallons per hour. Storage tank capacity is 756 times 1.25 or 945 gallons. So meron ka ng size ng heater sa kanyang storage tank. Kung ilang kilowatts, itong gallons per hour, multiply mo ng change of temperature. Showers and many mass housing installations such as hotels, military barracks, dormitories, etc. The peak hot water load usually results from the use of shower. Hotels will normally have a 3 to 4 hour peak shower load, and table 3 indicates the probable hourly hot water demand and the recommended demand and storage capacity factor to be applied. So, in motels, similar volumes of hot water are required, but the peak demand may last only for 2-hour period. In some type of housing, such as barracks, paternities, or dormitories, all occupants may, on some occasion, take showers within a short period of time. In this case, it is best to determine the peak load by determining the number of showers, the rate of flow per head, and estimate the length of time that showers will be on. The rate of flow from a shower head will vary depending on the type, size, and water pressure. At 40 psi water pressure, available shower head have a nominal flow rates from about 2.5 to 10 gallons per minute. In multiple shower installation, flow control valves are recommended since they reduce the flow rate and maintain it regardless of fluctuation and water pressure. The manufacturer's maximum flow rating can usually be reduced up to 50% without adversely affecting the spray pattern of the shower head. Flow control valves are commonly available in sizes from 1.5 to 4 gallons per minute. Installation. The storage tank should be installed as high as possible above the boiler. Hot water storage tank. Yan, tanke. The tank bottom should be at or above the boiler water line. Yung boiler, ito yung heater mo. When this is not possible and boiler water is the heating medium, a circulation pump should be installed to assure positive circulation of the boiler water to the tank. Resultant tank less than 20 inches in diameter are not recommended due to difficulty of preventing the entering cold water from mixing with hot water. Figure 12-13 illustrate piping arrangement from 1 or 2 temperature system. So ito yung typical hot water storage tank. A, ang boiler mo ito, heating element or steam supply. B yan. Merong tube, ano yan, saline tube yan. Saline tube. Heat exchanger. Kung steam. Yan. Galing sa boiler. Tapos, tank support, combination pressure temperature relief valve, Hot water circulating pump, G, thermostatic mixing valve, S, steam regulating valve. Ito. So, regulate mo kasi yung pressure na dyan. So, yung B, relief na. E, mixing valve. Isa lang ang temperature mo dito. Yan. 120 degrees Fahrenheit. Thermometer. So, sabi naman tayo dito sa Joule. So, yan. So, pag dalawa ng system. So, na ang piping niya. Okay? Dalawa yung pump. FNG. Napita yung FNG. Yan. Dalawa yung pump niya. Dual kasi magkaiba yung temperature. Ito isa lang temperature. So, ayan. May sample na kayo na diagram. Kala niya puro calculation ng pati diagram, pati drawing, dimension niya. Kaya kailanganin niya yan. Okay?